Welcome to Maths with Bob. Today we're looking at matrices and in particular the determinant of a matrix. You can only find determinants of square matrices. So that's the first thing. Obviously it's not defined for a rectangular matrix, for instance. We normally use these things for solving simultaneous equations, Cramer's rule for instance, which will be in the next video. But today we're just going to look at how we actually find this determinant and basically, if you like, what is it and some properties. So first thing is a determinant. Looks a bit, here it is over here. Let's have a look. Now, it looks a bit like an absolute value of something, doesn't it, really? So I suppose you can actually just think of it. Here's the original matrix, over here, A, B, C, D. It's called A, and its determinant is called DTA, space A, or if you like, A with some absolute value signs or on either side of it. So here is the determinant. Now, how do we find it? Well, basically we go this way, Chris, minus cross down that way. You can see here AD minus BC. So this is very important because this is, if you like, the basic determinant, and we reduce all our bigger determinants down to these 2x2s, and then we can just calculate this as a number. So the first thing to realize, obviously, is the determinant of a matrix is a number. Here's an example. Let's have a quick look. 5 times minus 9, minus 45, minus 6 times minus 4, obviously is plus. And 24, so it's minus 45 plus 24, minus 21. So here we have, so that is, if you like, that's the determinant of the matrix B. B is over. Let's see if I can actually make this a bit bigger. Move it across. Here we are. Here's B. Where's B? B is over here. Here's B. You can see 5, 6 minus 4 minus 9. And determinant of B is this, like the absolute value symbols on either side instead of the parentheses or brackets. And you can see here its value is, if you like, just minus 21. So the determinant of B's value is negative 21. That's not too bad. Here we have, you can see a 3x3 matrix down here. Now, the 2x2 matrices, well, and obviously their determinants are fairly easy to calculate, and they form the end of the line when you're expanding larger matrices, you can see here. So how do we expand a larger determinant? Well, basically we use what's called the cofactor method. Now, the cofactor method is formed by you either take you can take all the elements in a row and form their cofactors, or you can take all the elements in a column and form their cofactors. And you can see here, we're just going to stick with the first row or column. Now, interestingly enough, you can actually expand any determinant by any row or any column, actually. Now, there is this thing called an alternating sign here. Now, I'll just briefly explain this alternating sign now. Which is basically, I'll give a little bit of a pattern at the end, but basically it's just plus minus as you go across and down. And basically how you calculate it is it's minus 1 to the row number plus the column number. Obviously, if that's odd, then it's negative. If it's even, it's positive. So it's fairly easy. So it would go like positive, negative, positive, obviously positive, negative, positive down this way, etc., etc. And you'll see the pattern later. So what we're going to do is we're going to try and find the value of this determinant here. This is our 3x3 determinant, which we're going to try and find the value of. Now, obviously all the determinants are associated with their original matrices, and you can when we actually use these determinants, you'll see that the actual matrix comes from the coefficients of simultaneous equations, and you'll see a bit later on that this matrix, we use what's called Cramer's rule to work out the values of the variables. But we've got to get there yet. We haven't actually got there yet. But so we're on the path towards solving simultaneous equations, but we're just looking at determinants at the moment. So how are we going to work this determinant out? Well, let's go over here and have a look. I'm going to do it by the first row and the first column. So what we do, okay, so let's have a quick look. First of all, we're going to go work along the first row. Okay, here we have the 2, right? So we're going to take the -2, and you can see here it is, -2. And okay, and then we have a quick look at the cofactor matrix of the -2, which is, you can see here, you basically cross out the row and the column that your element is in, and you can see here you've got this one here, which is going to be a very simple 2 by 2. Okay, and we're going to work that one out. Okay, which you can see is pretty easy to do. It's -6 times 1, Chris, the old Chris minus the cross type idea, and I've done it all down here. Okay, and the first one is positive, so there's no real sign problem here. Okay, now the next one, the 7. Okay, now the 7. Okay, so the 7 is actually. Okay, I'll just move it up here. It's in. You can see it's in the first row, but it's in the second column. So it's -1 to the power of 1, 2. Well, sorry, it's the first row 1 and the second column 2, so it's to the -1 to the power 3, so it's -1. So it's -1 times 7, so that's where we get the -7 from. Okay, and while we're here, let's have a look at the 8. The -8, I should say. The -8 is in the first row and the third column, so it's 1 and 3 is 4, so it's -1 to the power 4, which is +1, so it's the -8 still remains as -8 over here. Okay. Right, so these are, so we have it like a plus, minus, plus, if you like, or plus, minus, plus in front of these numbers here, multiplying them by each of those numbers. So it's a plus times a -2, a minus times a 7, which is -7, and a plus times a -8. Okay, so obviously when we do the same for the 7, so okay, the 7 is actually, as you can see here, going to be, when we do this, we're going to obviously have the -7, but we're going to cross out its row, its column, I should say, in its row, and it's going to leave us with basically, well, it's a bit hard. I'll see if I can get this. Okay, so it's 3591, 3591. Okay, all right, because this one was crossed out and that one was crossed out as well. Okay, then we go across to the -8, obviously, and we just cross out its row and its column again, and then we have, okay, this cofactor. Okay, you can see here -3, -6. Okay, which, okay, as you can see, it's over here. Okay, all right. So once we've done that, we just now try and work it out. So it's -2 times, you can see here, -6 times 1, -9 times 2. Okay, which works out to be -24. Then it's -7 times 3 times 1, which obviously is 3 minus 45. Okay, it's -42 here. And -8 times 1, 3 2 is 6 minus, so it's +30. So it's obviously 36 here. Okay, -8 times 36. So the value is 54. Okay, so if you like, this determinant over here has a value of 54. And we expanded it by the first row. Okay, so now let's expand it via the first column. Okay, so we're obviously going to take these elements here and work out the if you like, the cofactor matrices. Okay. All right, so again, the -2 is basically the same as before because we're going down this way. So it doesn't matter if we want to cross that way. Obviously, this cofactor matrix will be the same, crossing out this one and this one. Okay, we've still got this. You can see here. Okay, yeah, again as before. Right. Okay, so then we'll come down. Okay, so it's plus times that. Then it's okay. So we're now, let's have a look at the 3. While we're here in particular. Now, it's -1 times this, now to a power, times that 3. Now, if you know the pattern, it goes plus minus, so it should be a negative, but let's actually try and work it out. So it's in the, well, it's in the second row and the first column. So 2 and 1 is 3, so it's -1 to the power 3, which is -1. This is where, okay, we get the -3 from over here. So it's -3, right? And obviously the 5 will be a +5. Okay, because it's actually -1 to the 1 and 3, which is 4. So it's -1 to the power 4, which is +1 times 5. And obviously, let's have a quick look. Cross out 5. Here we go. And we obviously left with this cofactor matrix here. Okay. All right. Okay. And we just have to work this out again, and you can see here it's minus 2 times, I guess before, minus 24 here, and minus 3 times 7 times 1, minus, which is minus times a minus is a plus, twice 8 is 16, and 7 obviously is 23 here, and 7 9 is 63. Now these two minuses make a plus, but then it's minus, so it's minus 48, so it's 15 here. And again, our result, as you can see here, is 54, okay, as before. Now, okay, all right, let's move on. Now let's look at some of the properties. Okay, now there's a lot of properties. There's actually 7 of them. Well, there's probably more, but I've just put 7 here, and I'll just quickly go through them. Okay, so you can see here the determinant of a matrix. Okay, let's actually put let's get a highlighter pen and just grab a yellow one. Okay, all right, so actually let's quickly go through here. Oh yeah, whoa, okay, you can see here the determinant may be expanded using the cofactors of any row or column. Okay, which is basically what we did a row and a column before. Okay, now we can also, a cofactor, okay, let's just try this one. Okay, if the cofactor expansion is attempted using one row and the cofactors of a different row, then the result is always 0. So you suppose you didn't cross out the right ones, for instance, you'll get 0, basically. So you've got to be careful how you do this, how you do the cofactor expansion. Obviously, you just cross out the row and column the elements in, and then form the matrix. I should say the determinant from the resulting elements. Okay, all right. Okay, now there's another one here. This is multiplication. You can just see this one by a constant. The multiplication of one row or column of a determinant by a constant multiplies the determinant by the constant. You can see here. Okay, it's the second row is multiplied by k, and it's just k times the determinant. Okay, that's not too bad. Okay, now this is an interesting one. Okay, basically it says, okay, if two determinants only differ by the elements of one row or one column, then you can add the determinants by adding the corresponding elements in that row. So what do I mean by that? Well, if you look here, you've got DEF, DEF, GHI, and GHI, and the only things which are different are obviously this one and this one. So what we do is we just add these two, okay, you can see here, and keep the other elements the same. Okay, all right, so that's quite a useful property of determinants. Okay, if you look at number 5 there, okay, let's just take some of these things off. Okay, if you look at okay, now if you start mucking around by changing, okay, the positions of rows or columns, you actually change the value, or the sign, I should say. It's actually just the sign of the determinant is changed. So if it's a positive, it changed to a negative, for instance. Okay, that sort of thing. Okay, so the last two. Okay, now this is quite important, this one. If are the same, then the determinant value. So if two rows or two columns of a determinant are the same, then the determinant's value is 0. Okay, that's very important. Okay, and we use that down here, actually, so we use that down there. Okay, as well. Okay, we'll use that in the next property, right? Okay, now this the last one is very important as well. Okay, so basically it just says it's quite a useful technique too. If you add a multiple of one row to another row, leaves, or for that matter for columns, it leaves the value of the determinant unchanged. Okay, so I'll just basically have a quick look at here. So you're adding k times row 3 to row 2. So row 3 is what? GHI. So you add KG, KH and KI to DE and F, okay, which is basically what I've done here. And we basically split them up using the previous property, okay. And then we take the K out using another one of the properties. And if you look at this one here, you've got two rows which are the same. So as you can see here, I've done it over here, two rows the same, its value is 0. Okay, so that manipulation didn't change the value of the determinant. Okay, very, very handy. And we're going to do some of this shortly. Okay, we're now going to try and expand a 4x4. And obviously, if you've got GeoGebra handy, okay, you wouldn't do this manually. Okay, let's have a look. Where's GeoGebra? You might remember how we did this with GeoGebra. Okay, that you just basically open up the spreadsheet, you right-click, you highlight the rows and columns, highlight, create a matrix, and I just usually rename it to A or something like that. And then in GeoGebra, you write here determinant, DT, it comes up, determinant of A, enter. Okay, it's 14. So we know the determinant of this matrix is actually 14. Now obviously you don't always have GeoGebra handy, but you can always check your answers with GeoGebra. Okay, so we know that this particular determinant has a value of 14. Now we're going to do some row manipulations. Okay, so the first thing is, if you have a quick look here, row 1 becomes row 1 plus row 4. So row 1, well, you can see you've got a -2 here. So if we just add that to the top row, we're going to get a 0 here. So our idea is to basically reduce elements to zeros if we can. Okay, now you have a quick look here. Now from there we move on. So we have a look at, we've got what, a 1 and a -1. Oh, that's quite handy. So if we do our row 2, make row 2 equal to row 2 plus row 3. So we just add this row to that row, we're going to get a 0 here. Okay. And also if you look over here, row 4, we've got a -2 down here. So if we actually go row 4 becomes equal to row 4 plus 2 lots of row 3. So if we actually go 2 lots of row 3 and add it to row 4, we're going to make this value down here 0 as well. You can see here 0, 5, 9, 11. Okay, so you can see here, as I said, good to go. Now, okay, so what's happened? Well, we've got 0, 0, 1, 0. So that's quite a good start. And we're going to expand it by the first column and the 1. So we're going to use the 1 here to expand it. But the trouble is it has an alternating sign, so it goes plus, minus, plus. You can see here -1 to the 3 plus 1, which is just +1. So it's 1 times, if you just basically cross out, that's actually, sorry, we'll just change the pen back. So I can now, okay, I'm going to cross out this column and this row and just form the 3 by 3. 4, 5, 5, 5, 2, 9, 7, 4, 11. As you can see here, over here. Okay. Okay, so basically this is, we've done a lot of reduction. Okay. Okay. Now I'm also going to work on the 3 by 3 and reduce. You can see we've got a 5 and a 5. So if we actually basically, you can see here we're going to go row 2 is going to become row 2 minus row 3. So we actually, if we just take this row off that row, okay. So 5 minus 5 is 0, 2 minus 9 is -7, and you can see here 4 minus 11 is -7. Okay, so that's a good start. Okay, and then we can just basically expand it by the first column again, using the 4. Okay, this 4. Okay, okay, just going to use that 4, which is positive. Cross out this row and column, and use -7, -7, 9, 11. Then we're going to move down to the 5. Now the 5, okay, the 5, okay, now has a sign plus, minus, plus. So it's actually going to be in the first, you can see column, and well, the row is actually 3, so it's 3 and 1 is 4. So it's 1 minus 1 to the power 4, which is positive. And you can see here it's 5 times its cofactor matrix. And Okay, so it's going to now give us 4. Now, obviously, minus 77 plus 63, 5 times minus 35, minus 49, so it's plus 49, so it's 14. As before, I mean, we used GeoGebra just to check this, but you can always use GeoGebra to check it, so its value is 14. So we expanded it now by, you can see here, the first row and the first column. Okay. All right, well, this is just finishing up now. It's been a fairly long video, but I just thought I'd show you the pattern. So the pattern is, you can see here, it's alternating plus, minus, obviously down here as well, but it's just -1, 2, okay, the row plus the column. And if you're in a row and column and those values add up to a negative, well, I should say an odd number, the value is going to be, of that particular element is going to be negative or positive accordingly, okay. All right, well, thank you for watching, and our next video will be I should say, on using these determinants. Okay, thank you for watching. Bye for now.